So let's look at acids and bases. And we know acids with a pH less than 7, they tend to be red, aqueous solution, and are neutralized by bases. That we know. Obviously we've got hydrochloric acid, we've got sulfuric acid, we've got nitric acid, and we've got obviously acetic acid, which is an important carboxylic acid. When we look at acids, we see the dissociation. Okay, we draw this in equilibrium to give us our proton plus our chloride ion. Obviously then this is our acid, this is our conjugate base, and this is our proton, which we really know is going to be H3O plus, the hydronium ion, which we'll look at in a second. We know that this proton concentration is measured by pH equals minus the log of the hydrogen ion concentration. The stronger the acid, the greater the dissociation. So strong acids, greater dissociation, and greater dissociation means more hydrogen ions produced. So stronger acids, greater dissociation with the red line. That's obvious because here chloride has 8 valence electrons. It's going to be stable, so there's lots of dissociation. So we take this a step further and we look at HCl reacts with our water molecule. Okay, water we know has lone pairs of electrons. The water will pick up the proton from the acid like so to give us OH, HM plus, which is our hydronium ion. And as well as doing that, we also get the chloride, Cl minus. Okay. We can see here that the definition is that the water is acting as a base and the HCl is acting as an acid. In terms of our definition, it is a proton donor. See, it is donating its proton. Secondly, it is a lone pair acceptor. It is accepting lone pair of electrons from the water molecule. Here's the lone pair. It's accepting them. And we see that the pair of electrons indicates that this green arrow is a bond being made. And this bond arrow indicates a bond being broken. So we have a pair of electrons indicated by this arrow making a bond between the oxygen and the hydrogen, and simultaneously a bond between the hydrogen and the chlorine breaking. So here's our new bond formed, and the chloride is lost from the other new bond being formed. So we fulfill our definitions that if the acid forms a hydronium ion, it is a proton donor, it is a lone pair acceptor. Those are our great obvious definitions of a Lewis acid, Arrhenius definition of a hydronium ion, and acid proton donor being the Bronsted-Lowry definition. So there are our definitions.